All right, so I just want to pick up on something like number 4. Let's take number 4. All right, because you are so used in solving for y. And then we say, okay, guys, let's solve for y so that y is the only one that exists. The first thing you cannot think of here, you say, well, I'm going to pull out the common vector of y. All right, good shot, go for it. Now you pull out y, and now in the parentheses, you've got x squared, you got plus x, and then there is a y, and then equals to 6. And then when you divide, you now have y equals to 6, and then all over x squared plus xy. And then, whoops, you still have a y there. You need to move it out. It must be there. You're like, oh my gosh, I couldn't solve for y. You see that? That's the key. That's the thing. That's the idea with implicit. Not others you can, but actually it helps you to solve things where you cannot solve for y. All right, so that was the point now. I think you get a hang of this one here. All right, so let's do this one. All right, so now let's deal with this one. I know we can do number 2 and number 3 unless the guy says, hey, these guys, they can't do this. No. First, let's look at this one here. This is a product rule. Like, I'm going to put a dot there to impress in my thinking. Sometimes I just put them in parentheses. I said, okay, you guys, you'll have to stop the first. I'm going to stop the x squared. So the focus is on the first term, which is the product rule. You know? That's a product rule, that one there. Hold on. All right, so we stop the first, the x squared, because that's how you've been taught, but me, I wouldn't. Then you derive the second. So the second, remember, you're doing the derivative of that y. In other words, if I write it, I'm actually doing this. I want the derivative of y, dy. Normally, we put that in bracket like this too. So I'm deriving the y. But if it's one term, no need to do that. We just say dy all over the dx. That's all there is to that part. But we need to say plus, we stop the second, that y. You derive the first, so it's going to be 2x. It's going to be 2x multiplied by the y. That is the first term. Next one. We need to work out with that one. So it's going to be plus. Again, you stop the first, which is x. You want to derive that one. Remember, when you derive, the 2 comes in front. So it must be 2y, and then times by the derivative of the base. I mean the derivative of the dy all over the dx. But I don't like to have it x2y. That 2, I'm going to shift it to the other side. That 2 should actually move here and be the coefficient. It looks beautiful if written in that manner. Then I do that. Next thing, plus. I derive the first. When you derive x squared is really 1 times the second times y squared. There it is. Equals to, derive the 6. Well, it's a constant. It's 0. Are we together now? You're not lost, are you? Then what's in the box? It's my dy over dx. I need to pull it out. I must solve it for that. But I can see here I've got the y squared, and I also have the 2xy. I need to take them over those 2 terms. Let me do that for you because we just started this thing. So let me not go very, very fast. Let's take it step at a time. I'm going to shift everything that is not that is not a like term to dy over dx. So I'm taking the boxes together, and then plus it will be 2xy, and then times the dy, and then all over the dx, and then all other terms are shifted to the other side. So I would have the minus 2xy, can you see that? And then minus the y squared. There we go. Now on this one here, I just have to pull out a common factor. So if I pull out a common factor, this is what I've got. So I'm going to have dy all over the dx, and then in the brackets we've got x squared plus 2xy, close the parenthesis, equals to, these are your videos that are showing up here, equals to negative 2xy minus the y squared. And then whatever is in the green box must go and divide the other side, isn't it right? Yeah, then we could write therefore dy all over the dx. This one you couldn't solve for x, for y, so there's no way you are going to replace it. You absolutely aren't. But most of the time you find out the y normally cancels out. Alright, so I've got minus 2xy minus the y squared all over x squared plus 2xy. Now you see it says dy over dx. That becomes your answer. Are we good?